Hi viewers, welcome to LMS Solution. Today we are going to see about grid-connected PV wind battery system with the Fuzzy MPPT algorithm. The Fuzzy MPPT algorithm is implemented for solar PV system as well as a wind energy conversion system to extract the maximum power from the wind energy as well as PV panel. Here you can see that we have the Fuzzy MPPT for the wind energy conversion system. The system consists of wind energy conversion system. Then when wind energy conversion system having wind turbine, PMSG, a rectifier, boost converter, and then this and the boost converter output will be connected to the DC bus. The DC bus voltage maintained at 400 volt. The rating of this wind turbine and PMSG is 3 kilowatt maximum, and this boost converter will be controlled by means of the first MPPT. It receive two inputs. One is the rectifier voltage and the rectified current. Based upon that, the first MPPT will be generated duty cycle. When we go inside, we have to calculate the following detail. That means we have to calculate P of n and P of n minus 1, and then change in power P of n minus P of n minus 1, and then here we have to calculate V of n minus V of n minus 1. This is nothing but del P, and then this is nothing but del V. After that, here you have to take the ratio between del P divided by del V. The del P divided by del V here known as slope of the that wind turbine characteristics. Here we are going to consider the del PV divided by del V known as error, and then you have to calculate change in error and error. So the error and change in error will be given to that physiologic controller. The physiologic controller will be generate the duty cycle. Duty cycle will be processed via PWM generator. This PWM generator will generate the pulse. This pulse will be controlled this MOSFET of the boost converter in order to extract the maximum power from the wind energy converter. The same way, here we are using solar PV system. The solar PV system rating is 2000 watts. Is going to be connected to the DC bus via this boost converter. The boost converter will be controlled by means of Fuzzy MPPT algorithm. Here, the Fuzzy MPPT algorithm receive two inputs, PV voltage and the PV current. Again, same way, by using that current and the voltage to calculate del P and del V, and then del P divided by del V going to be considered as error, and then you have to calculate change in error. Error and change in error is given to that physiologic controller. Output will be known as a duty cycle. This duty cycle will be processed via PWM generator. So this PWM generator will generate the pulse. This pulse going to be control this IGBT of that boost converter in order to extract the maximum power from the solar PV system. And then here we have battery energy conversion system. Battery going to be connected. Battery rating is 12 into 20 volt. That means a 12 volt battery, and then rated capacity here we are considered as 40 Ah, and it will be connected via bidirectional converter. Here the current flow will be in both direction based upon the power balance in the system, and also this bidirectional converter is used to for maintaining the DC bus voltage at 400 volt. This bidirectional converter going to be controlled by means of voltage control method. That means here you need to measure the load voltage, otherwise called DC bus voltage, and the DC bus voltage will be compared with the reference voltage 400, and then both are compared here, and then the error when we process via PI controller. The PI controller will be generate the duty cycle. So duty cycle will be processed via PWM generator. It will generate the pulse. So this pulse will be control this the 2 IGBT of this bidirectional converter in order to maintain DC bus voltage which is equal to 400 volt. So next you have to see about the grid integration. We have grid with the 230 volt RMS 58 supply, and then here we have two load. One load is around 1000 watts, another load have 1400 watts. The 1000 watts will be connected initially, and then this 1400 watts will be connected after 2 seconds, and then going to be connected to the LCL filter and the inverter. This inverter when be controlled by means of current control concept. That means we are going to measure, that means we have to measure the IPV and SOC. Based upon that we have to decide that means reference current for that inverter. When IPV is less than 0.5, SOC is less than 10%, the higher reference we are decided is minus 10. That means minus 10 means the grid should be supply the power to the grid, because here there is no power in the PV and the SOC. That when there is no charge in the SOC, we are taking power from the grid. When IPV is greater than 5, the SOC is greater than 10 percentage. So we are supplying some power to the grid, the current reference up to amps. So for this condition, IPV less than 0.5, SOC less than 10, current reference is minus 10 amps. That means the peak current we are taking minus 10. When IP is greater than 0.5, SOC is greater than 10, the reference current is 2. That means we are sending power to the grid with a current peak of 2 amps. After that, here we need to measure the grid voltage, and then from the grid voltage you have to calculate sine and cosine. This reference current in the form of magnitude only. We need to convert into sinusoidal form. That's why you have to multiply sine wave, and then it will be converted into like transformation. You have to use transformation like alpha beta to DQ transformation. By using alpha beta to DQ transformation, you have to generate the reference in the form of DQ, and also here you need to measure the inverter current. Here you need to measure the inverter current. That inverter current when we convert it into alpha beta to DQ not form. So here we are converting alpha beta to DQ. After that, the actual the DQ and reference DQ when we compared here, and then going to be processed via PA controller. So this is a current PA controller. The current PA controller will be generate the controlled voltage in the form of D and Q. Again, the D and Q will be converted into alpha beta, and then you have to take only alpha quantity. So this alpha quantity will be processed via PWM generator. So this PWM generator will generate the pulse to control the inverter. So this inverter can be controlled based upon the current reference is decided from the condition of SOC and the PV current. It will be operate in both direction. Inverter also can be operate in the both direction. So this is the model and the control logic of the system. So next you have to test the model. First I'm going to explain about the conditions we made in this simulation. That means the wind speed is initially 12 meter per second from 0 to 2 seconds. After that the wind speed changed to 10.8 meter per second after 2 seconds. And then here we are making the radiation. The radiation will be changed every 0.3 seconds. Initially radiation will be 1000, after that change to 500. After that it changed to 10 watts per meter square, and then again change to 500, 1000. After 1.2 second, the irradiation maintained at to 1000 watts per meter. And then earlier I explained about the AC load. The AC load here initially it have 1000. After 2 seconds it changed to 2400, and then here we have DC load. So DC load we are using 1000 watts. Next you have to simulate the model. Already we simulate this model and then take the results. We have to explain. I am going to explain the results of the simulation model. Here you can see that this is a PV voltage, current and power. So initially the PV is around 2000 because the radiation maintained at 1000 watts per meter square. After 0.3 second, the irradiation changed to 500. Because of that, the PV power changed 1000. After 0.6 second, irradiation changed to 10 watts per meter square. That's why the PV power goes to 0. And then it's the variation of PV current. So initially it is 8 amps. After that 4 amps. After that it comes to 0 amps. And then this voltage of the PV, if is maintained around 245 volt. And during that low irradiation condition is maintained around 50 volt. After 1.2 second, after 0.9 second it changed to 500 watts per meter square. That's why PV power is maintained 1000 watts. After 1.2 seconds the irradiation changed to 1000 watts per meter square. That's why we are getting power 2000 watts from the PV panel, because rated power of the PV is 2000 watts. After then it will be maintained at 2000 because after 1.2 second irradiation maintained at 1000 watts per meter square. That's why we are getting 2000 watts from the PV panel. So next time I would explain about this rectifier power and boost converter power. That means this rectifier power of the energy conversion. So initially the speed of the machine is 12 meter per second. So here we are getting around 3000 watts. After 2 seconds, right, the wind speed changed from 12 meter per second to 10.8 meter per second. Because of that we are getting around 2100 watts. This is variation of boost converter power of the wind energy conversion. Next you have to see about this battery voltage, and then this is battery current SOC of the battery. Here you can see that initially battery current is going to be maintained around 10 amps. After that this comes to minus 15 amps. After that comes to minus 17 amps. After this comes to minus 22 amps. Why? Because during this time the PV power is goes to 0, around 0, and then PV current goes to less than 0.5, and then you can see that the SOC of the battery is less than 10% only. initially from 0 to 0.6 seconds. The wind, solar and battery sending power to the load, AC load around 2 amps, 2 amps peak from 0 to 0.6 seconds. After 0.6 seconds, what happened? The irradiation change from 500 to 10 watts per meter square. Because of that, the PV current goes to less than 0.5, and then during that time, right, the association of the battery is less than 10 percentage. Already we made some condition in the inverter control. We are getting power from the grid. That means we are getting minus 10 amps peak current from the grid. That you can see here. Here the grid current changed. Initially it supplies some power. So that power will be around 700, because initially the AC load will be 1000 watts. The solar PV, wind and battery supplying 300 watts. The remaining power will be get from the grid for the AC load. That's why grid supplying 700 watts and the solar PV, wind and battery supplying 300 watts initially. After 0.6 seconds, what happened? We are getting power in the grid, because associated the battery is now less than 10 percentage, and then PV current is less than 0.5. That's when the grid power increased from 700 to around nearly 2500. So this is because of this condition. IPV is less than 0.5 and the SOC is less than 10 percentage. We are getting power from the grid. Next, you have to see during that change of rectifier power here in 2 seconds. This will be also affected the battery current, battery charging also. During 2 seconds, grid power is increasing, because we are increasing AC load from 1000 watts to 2400. So in order to supply that 2400, we are getting power from the grid alone, because of this condition we are getting only power from the grid. That's why the grid power is increased from 2400 to around 4100 watts. So and also you can see the some changes in the current, the battery, because during same 2 seconds what happened, the wind power changed from 3000 to 2100. That's why the charging current of the battery decreased from minus 22 amps to minus 17 amps. So based upon the condition, we are sending power to the grid from wind, battery and the solar. Then IP is less than 0.5 and air source is less than 10%. Then we are getting power from the grid. That is the operation of the system. And here you can see that this is the load voltage and the load current of the AC load, and then this power and the power of the AC load. And here you can see this variation of grid current, grid voltage in grid power. This is a variation of grid voltage in the current grid power. And then you can see another detail, so inverter detail. This is a variation of inverter voltage, inverter current and grid current. Here you can see that during from 0 to 0.6, inverter voltage and inverter current both are in phase. When you can see that after 0.5 seconds what happened, the condition when we change, we are getting power from the grid. So that's why I am seeing that the inverter voltage and inverter current both are opposite each other. What's the meaning? We are getting the power from the grid. When and the inverter voltage, inverter current both are in phase, then solar PV, wind and battery giving supply to the grid. When inverter voltage and inverter current is both are out of phase, then we are getting power from the grid to this system. So this is the operation of that grid connected PV system with the Fuzzy MPPT algorithm. With the Fuzzy MPPT algorithm, you can see that we are extracting maximum power from the PV, and then we are extracting maximum power from the wind also. So this is working of this model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.